Now the projections from three wheels of different sizes are shown at the right of the screen. Each of the three wheels rotates with the same frequency. We can easily see that the largest of the three wheels produces the largest displacement on the waveforms at the right. As the dots on the circles move through the various angles of rotation, the magnitude of displacement corresponding to any particular angle varies with the size of the wheel. We can see, though, that each of the three waveforms has the same general shape. The unifying concept that explains the common shape is called the sine of an angle. No matter how large the size of the circle, the sine of some particular angle is a constant value. For example, with your pocket calculator, you can confirm that the sine of a 0-degree angle is always 0. The sine of a 45-degree angle is 0.707. The sine of a 90-degree angle is always 1. The sine of a 270-degree angle is always -1, and so forth. Motion of the three wheels now is halted at a 45-degree angle. We can see that the displacement of the three dots on the waveforms are different in magnitude. But in each case, the upward displacement of the dots is 70.7% of maximum. That is because the sine of a 45-degree angle is 0.707. In other words, the sine of any angle, 45 degrees in this case, tells us what proportion of maximum displacement has been reached. Now each of the dots moves to 90 degrees. The sine of a 90-degree angle is +1. The value 1 tells us that we have reached 100% of maximum displacement. The plus sign informs us that the displacement is positive or upward. Next, the dots move to 135 degrees. The sine of a 135-degree angle is the same as the sine of a 45-degree angle, 0.707. Thus, each of the dots on the waveforms has returned to 70.7% of maximum displacement. The sine of a 180-degree angle is 0. That means that the displacement at 180 degrees is 0% of maximum. The dots are at equilibrium. The sine of a 225-degree angle is -0.707. The value 0.707 means that, once again, displacement is 70.7% of maximum. The negative sign tells us that the displacement is negative or downward. What do you expect at 270 degrees? The displacement is 100% of maximum, but in a downward or negative direction. Therefore, we should reason that the sine of a 270-degree angle is -1. Because the sine of any particular angle is a constant value that is independent of the size of the circle, if we display the sine of the angle instead of the absolute displacement for that angle on the vertical axis, the three waveforms should be superimposed.